Have you ever really thought about what it takes to keep the lights on? Or how the heck the price of that electricity is even set? Well, it's not magic, that's for sure. It's this high-stakes world where data, math, and believe it or not, storytelling all come together. So picture this. Our entire world is powered by this huge, intricate grid. And it's not just one thing, it's two. You've got the physical market, for actually moving the power around, and then there's the financial market for trading it. And both of these are operating on a scale that is just, honestly, it's almost impossible to wrap your head around. And with every single sensor, every smart meter, every single trade that happens, it's all generating data. We're talking hundreds of gigabytes of the stuff. It's coming from government agencies, from private companies, creating this constant, just overwhelming flood of information. So, right. That's really the billion-dollar question, isn't it? How do you even begin to make sense of all that chaos? How do you find the important signals in all of that noise? The signals that let us optimize our energy systems, cut costs, and, actually speed up the move to cleaner energy. To get those answers, we're going to need a guide, someone who speaks both languages, energy and data. So let's follow a new kind of analyst, the Modern Energy Quant, and dive right into the heart of this incredibly complex world. All right, first up, we're exploring what I'd call a new energy frontier. Okay, so this is where we meet our guide. Let's call them Alex. Now, Alex is a quantitative analyst, or a quant. And listen, when you hear quant, don't picture some 80s Wall Street movie. The Modern Energy Quant is totally different. They're a hybrid, part data scientist, part deep industry expert, and a lot of the time, they have this real passion for sustainability. Their whole job is to build these complex math models to find an edge in the super high-stakes energy market. So what's the first thing Alex has to deal with? It's taming that massive flood of information we just talked about. We're talking a full-on data deluge. So where does all this data even come from? Well, here's the surprising thing. A huge chunk of it is actually public. You just have to know where to find it. I mean, we're talking about enormous data sets from federal agencies that track literally everything. You've got the EIA tracking power plant fuel, the EPA on emissions, FERC overseeing grid finances. It's a gold mine of info. But, and this is a big but, it's incredibly messy. That's exactly why these open source projects, like the Public Utility Data Liberation Project, they call it POODLE, are so crucial. They do the hard work of cleaning it all up for analysts like Alex. Okay, so let's get into the quant's toolkit. What exactly does it take to rustle all this data into something you can actually use? All right, here it is, the Modern Quant's toolkit. It usually starts with getting really, really good with spreadsheets for modeling. But then you quickly move on to programming, most often Python with its super powerful data libraries like pandas. You absolutely need SQL to pull data from databases. And kind of holding it all together, you need solid stats skills and a real knack for data engineering, which is just a fancy way of saying you're building automated systems to handle that constant flow of data. So one of the very first big tasks for any quant is this process called ETL. It stands for extract, transform, and load. First, you extract the raw, messy data from all those different places. Then, the really important part, you transform it. That means cleaning up errors, standardizing everything, getting it structured. And finally, you load that nice, clean data into a database where it's all ready for analysis. Honestly, this is the grunt work, the foundational stuff that makes all the cool analysis possible later. All right, now for the part we've all been waiting for, the payoff. From data to dollars. Now that the data is tamed and the tools are ready, let's watch Alex tackle a real-world problem, helping a client find some serious savings that are just hidden inside their energy bill. So the client thinks they know what's up. Their energy use is high during the day, right? And then it drops way down at night. Simple. But Alex gets a hold of their 15-minute interval data from a smart meter. And when Alex starts to plot it out, oh boy, the data tells a completely different story. There's this massive, mysterious energy draw happening all night long. And here it is, the aha moment. The chart just lays it all out. There's this huge, flat line of energy consumption all through the night. It's almost as high as the peak during the day. And what's the culprit? The building's AC system was programmed to run 24/7, just blasting cold air into a totally empty office building. And look, this isn't just some fun little factoid. That one single insight from the data, it pointed to over $150,000 in potential savings every single year. That is the power of turning data into actual dollars. You know, as one industry expert on Reddit actually put it, data analysis is ultimately trying to tell a story. And that's exactly what happened here. Alex didn't just find a number, they uncovered a whole story about waste and gave the client a clear, actionable way to become more efficient. That's the story they needed to hear. Okay, so that was one building. Now let's scale that thinking way, way up. We're going to take that same logic and apply it to the entire power grid as we dive into the world of treating, risk, and the grid. So what you're seeing here illustrates a huge challenge for the grid. See, operators always want to use the cheapest power they can find. But what happens when a transmission line, think of it like a highway, gets totally jammed up? A bottleneck. Well, to keep your lights on, they're forced to fire up a more expensive local power plant instead. And predicting when and where these bottlenecks are going to happen, that's a massive part of an energy quant's job. So how do companies deal with the insane financial risks that come from these price swings and bottlenecks? Well, they use a strategy called hedging. The easiest way to think about it is like buying insurance. They use financial contracts to lock in prices, which protects them from those wild, unexpected spikes or crashes. It's what keeps them from going bankrupt if the market suddenly turns against them. Okay, but here's where energy markets get really, really weird and fascinating, something that makes them totally different from other financial markets. So normally, right, you get paid a little extra to take on risk. But in energy, the market price of risk can be positive or even negative. Now, what does that mean? It means that, depending on the season, future energy prices can be consistently skewed to be higher or even lower than what you'd logically expect. It's a completely unique modeling challenge that makes this field unbelievably complex, even for a seasoned quant like Alex. So if you're listening to this and thinking, hey, I'm kind of like Alex, you're analytical, you're curious, maybe you're passionate about energy, you might be wondering what a career in this field actually looks like. Which brings us perfectly to our final section, the modern energy career. So the path usually starts with a degree in something quantitative, like physics, math, or computer science. As an entry-level analyst, you'll probably spend your first year or two really focused on that data cleaning and building the basic models. But as you get more experience, you get to move into the really cool stuff, developing complex trading strategies and risk models. And eventually, a senior quant can become a real leader, driving research, innovating new approaches, and maybe even becoming a partner at their firm. Look, our energy system is right in the middle of a massive, historic transformation. It's getting cleaner, it's getting smarter, but it's also getting infinitely more complex. So that leaves us with a huge question for the future. As this tidal wave of data just keeps getting bigger, who is going to be there to find and to tell the incredibly important stories that are hidden inside of it? Well, the answer, more and more, is the modern energy quant.